These should look familiar. So we have 4 different types of factoring that is in this little chart, using the different methods of factoring quadratics. So we have a general trinomial, which means it doesn't have a special pattern. You just have to use the traditional taking a times c and multiplying it together. We have the perfect square trinomial, 3 terms, the first and the last are perfect squares, and then the difference of 2 squares. So those 2 would be our special patterns. And then the last one, it just says there's a common factor. That's like a GCF problem. So see if you can get those to factor. You can just factor it right next to it on the right side there. There's space. But just a nice little review of factoring. You will have a little factoring quiz that looks like this, not with the larger powers, but very similar to those problems, either tomorrow or Friday. So expect a short factoring quiz tomorrow or Friday on these 4 examples, similar to those 4. So Michael, how would you factor the first one where it's just a general trinomial? Ax squared plus bx plus c. So he said -8 and 5. And then, Michael, what would you take out of the first pair? And out of the second pair? Good. So this only works if the quantity in parentheses is the same, and then you can combine the terms in front of that quantity that's the same, and then we have the x minus 4. Bless you. Bless you. So a general trinomial is that form ax squared plus bx plus c. That's the standard form of a parabola. That's just a general ax squared bx plus c. So the second one is a perfect square trinomial. Chris, how would that factor?
So since there's no coefficient next to the x,
Yeah.
you square it, and you square root 16 and become x plus 4.
So when it's a trinomial and they're perfect squares, the middle number has to be 2 times the 1 and the 4. So the 1 and the 4, which it is an 8. And then it's just the square root of both the first and the last term, either with a plus or a minus in the middle. And this one gets a plus because it's a plus bx. The third one says 9x squared minus 1, and this is the difference of 2 squares because both of them are perfect squares, and there's a minus sign in the front, or in the middle, not in the front. How would that one factor? Ava, how do you have that factor?
3x minus 1.
Yeah. It's also known as the sum and difference. So one of them is a sum, the other one is a difference of the same quantity. And then the last one says a common monomial factor. That just means they have a common term. So what would their common value be?
4.
Yeah, they have a 4x in common. It's just like saying a GCF. And then what does that give you in the parentheses?
12 plus 5.
Okay. So factoring means breaking something down into multiplication. These are all different types of factoring because my end answer is still a multiplication problem. The other goal The zero product property would enable me to solve for all the x's in the parentheses. But even though you're just taking something out, a GCF, that's still factoring because it's now changed to multiplication. So there are a couple of terms underneath this to look at. And we're going to be talking about something called a prime polynomial. If a number is prime, what does that mean? So if a number is prime, what are prime numbers? Right, so any number that can only be divided by 1 in itself. Well, polynomials, we also have a prime polynomial that works the same way. So now it's a whole equation that's prime. So if I look here, once they're factored, if I can't factor it any further, so whatever's in parentheses, if it can't be broken down any further, then it's called a prime polynomial. And that's what our goal will be. So we're going to be factoring these larger powers, trying to break them down so they can't be factored any further. So a polynomial with 2 or more terms is a prime polynomial if it can be written as a product of polynomials of lesser degree using only integer coefficients and constants, which is a lot of wording there. So essentially, as long as it's broken down using numbers and constants, and if the only common factors of its terms are the number 1 and itself. And that's the key part there. So when we break it down, I want to look at the answer and say, all right, the answer is prime because it has nothing in common, there's not a GCF, and I can't continue to factor it any further. So the only thing it has in common is the number 1 and itself. So if you look at the example that's underneath here to try and make a little more sense, we have 16x to the 4th minus 4x plus 8. Can you do anything with that polynomial or trinomial in order to break it down any further? Josh? Right, we can take out a 4. So if you take out a 4, that means you're doing something to break it down. There's still more to do with the problem. So if you take out a 4, Josh, you get
4x squared minus x plus 2.
So then the next step, after you take out a 4, if I need to decide if this can still be factored further, how do we check to see if this can still be broken down further, Josh? What would the next thing do? Kind of like, right, so the next thing we would want to check is, can you still factor it? And the way to check that is by multiplying and seeing if there are factors that work. So Josh, multiplying 4 and 2 gives us 8. And then are there factors of 8 that combine to be negative 1? No. So 8 would be 4 and 2 or 1 and 8. So we need to check, can it be factored further, meaning can it be broken down further? And the way we check that is multiplying 4 times 2 and seeing if there are any options to give us a negative 1. If there aren't, then whatever's in parentheses, which is 4x squared minus 1x plus 2, is called a prime polynomial. So essentially, if I can't factor it further, it's prime. Yes, we could still solve it differently, but we're just trying to factor it. So this is a prime polynomial because 1 is a common factor of all the terms, and there are no other common factors of all the terms. So we took out the GCF, we took out a 4, but that part that was left can't be broken down any further. So that's called a prime polynomial.
So 16x like the original problem wouldn't be a prime?
Correct. The original problem is not a prime polynomial because we could factor it further by pulling out a 4. So as long as you can do something to it, it's not a prime polynomial. But if you're left with that part in the parentheses and there's nothing else we can do with that, then it is prime. Other questions? So our goal will be to factor completely. Those are usually the words you'll see. Factor completely, but we want to make sure our polynomial is considered prime or isn't factorable any further. It can't be broken down. So you see those words, factor completely. A polynomial is factored completely if it is written as a monomial, or the product of monomials with one or more common polynomials. Oops, spelled that right. So completely. Can we break it down as far as it can go? So it says x plus 2 times x squared minus 5x plus 6 is not factored completely. Because why, Chris? So he said we can break this down further, and you're so close. If you use x minus 6 and x plus 1, Chris, what's wrong with using those two numbers? If you multiply negative 6 and 1,
Oh.
you need a plus 6 in the back. What else makes sense? 3 and 2. So we would have x minus 2 and x minus 3. So the original problem, x squared plus or minus 5x plus 6, that second part is not factored completely, so it's not prime. If it can be broken down further, then we can still factor it further. So it's not factored completely because it can be broken down. And once we can break it down, then it's factored completely. So what we have left here, these are linear, x minus 2, x plus 3. Can't factor that any further. They don't have a GCF in common. So factoring completely, breaking it down all the way so that my parentheses is prime. It doesn't have any common factors. Questions? So there are two more terms. The one term at the bottom you know, quadratic form, and the other one we actually use factor by grouping when we're factoring quadratics. Anybody explain what factor by grouping is? How could you explain that? It's kind of hard to explain. You know how to do it, but what does it really mean? Peter, what do you think? And like going above here, this up here is factoring by grouping because we kind of grouped two terms together and two terms together. So like you're pulling things together because they have something in common. So we'll say pairing terms together because they have common factors. Or common terms, I guess. So factor by grouping. Grouping means kind of pairing things together. Or I might be putting three things together because they have something in common. But the key thing is you're putting them together because they have something in common. So factor by grouping, you're pulling two things together, maybe three, because they have something in common. And then the last term underneath here, what's quadratic form? Nick? Yep. That was all of chapter 4, quadratic form. So we might be trying to get our equations into quadratic form so that we can then factor them from that stuff there. So we reviewed at the top of the page and yesterday the 4 different methods that we use to factor. There is one other type of factoring, and that's at the top of the next page, because not everything is going to be in the quadratic form. Not everything is going to have an x squared. So at the top of the page, there are, yes, a couple more special patterns. So math has a lot of different patterns in it. Geometry had different patterns in it, but with algebra and x terms, there are more than just terms that are squared because they could be cubed, they could be to the 4th, they could be to the 6th, so my powers can change. And if they meet a special pattern, then we have a way to factor them. So this pattern works for the sum of 2 cubes or the difference of 2 cubes. And they must be cubes, and there can only be 2 of them. So like the difference of 2 squares, a squared minus b squared. So this pattern only works if they're cubes. So now you have to think of like what numbers are cubes. So like 2 times 2 times 2, 3 times 3 times 3. So the pattern, we like to use the word soap to help you remember the pattern. I know it seems weird to use the word soap. But soap helps us remember the signs in between the letters. So the S stands for the same sign. So that means if I start with a plus, my first sign should be a plus. They're going to be the same. So if I have a plus in my original problem, my first sign should be a plus. What do you think the O would stand for? Opposite, yeah. So O stands for the opposite. So if I look, my next sign is an opposite sign, and that works in both of them. So I have the same sign, and then I have an opposite sign. And then the A and the P kind of go together. It ends with an always positive or a plus sign. Peter, if you go home and ask your brother about soap, he will still remember soap. And if he doesn't, I might have to hit him. So that I can hit him if he forgets. Yeah. So we're going to look at this pattern. And I know I just talked about patterns last week as well. You can ask Emma too. She better remember soap. She better remember it. I might not hit her though. She's too sweet. So we have A cubed plus B cubed. The way it factors is A, same sign B. A squared, opposite sign, A, B, B squared. There's always a plus in there. So if you can figure out a little song to go along with it. Jack, do you like to create some songs? Do you like to make up songs? You seem like a little rapper back there. You are a little rapper? No?
Definitely not.
Definitely not the rapper back there. Maybe Michael? No. So maybe come up with a little jingle. Since it's a holiday season, you could come up with a jingle to get this to factor. Josh is the rapper?
Yeah.
So A, same sign B. A squared, opposite sign, A, B, always positive B squared. So if you look at the first two examples, just to kind of get us to factor this, and I know it seems weird, but I promise, like, we'll use it. You'll use it again later in the year. We'll use it again later in the year. You'll use it all throughout next year. It really just kind of gets ingrained. So same sign, always, then opposite, always positive at the end. So we have x plus 8. Our goal is to factor it with this pattern, A, same sign B. A squared, opposite sign, AB, always positive B squared. So my A term and my B term, instead of taking square roots, now we need to take cube roots. So this is x cubed. The cube root of x cubed is just an x. So that's how we get an x here. The cube root of 8 is 2, because 2 times 2 times 2 makes 8. So that's why there's a 2 there. So we're taking cube roots instead of square roots, because these are perfect cubes. So then when we plug it into the formula, we have A, same sign B. And then I have to square A, so x squared, opposite sign, and then I have to take A times B. Well, that's taking those two numbers, or terms, and multiplying them together. So x times 2 is 2x. Always a plus sign. And then my last one is b squared. So b is 2. We have to square it. So here's my a term and my b term. So a and b, I'm taking cube roots to find those numbers. So if you look at the one next to it, we have 8x cubed. So we need to take the cube root of 8x cubed. And that would be 2x. And then we need to take the cube root of 1, and that's just 1. So here's my a and b, which is how we have that 2x minus So then when you go to plug it in the rest of the formula, we have to take a squared. What is 2x squared? Chris? Right, that becomes 4x squared. So this is really 2x, my a term, and you're squaring it. Then I need the opposite sign. So I started with a minus, the opposite is a plus. And I need to take a times b. So 2x times 1 is just 2x. Always positive at the end. And then my last term is b squared. So again, a squared, ab, b squared. So I start with an a to b, and then in my second parenthesis, a squared, ab, b squared. Soap in the middle.
So for like the middle parentheses right after the sign, it says 2x like minus 1. Would you just like always have it like positive 1?
So the minus sign in the middle there?
Does that like affect the
No. So this sign here kind of drives the other signs in the middle. But these signs are the soap. So this is the same as what I started with. The opposite of what I started with, always a plus sign. So this is the part that kind of determines the three signs that are left. And that's why we have that soap. So same, opposite, always positive. Other questions? So there are a couple examples underneath trying to use this. And the directions say to factor completely using the sum or difference of two cubes. So the first thing we have to kind of think about, what would the perfect cube be? Because we're now using cube roots. So we have z cubed, so we're taking the cube root of each of them. So Gavin, the cube root of z cubed is just z, and the cube root of 125 is 5. So a, b. Those are my a and b values. So now I have a minus sign. So the pattern is AB in the first parenthesis, A squared, AB, B squared. That's always the pattern. AB, A squared, AB, B squared. And then the symbols are soap. So if I have a minus sign, I have a minus sign because it's the same. And then the opposite, and then always a plus. Soap represents the symbols in between. So Gavin, it would factor as
z minus 5 and z squared plus 5z plus 2.
nice. This back trinomial will always be prime. It cannot factor further.
Wait, so b would be positive 5?
Say it again.
B would be positive 5 instead of negative 5?
Right here.
For like the first one.
Oh, over here.
Yeah.
This minus sign has no effect on the cube root of a and b. So the minus sign gives us these symbols here. So the minus sign gives us the symbols or the signs in the factoring. But you're just looking at like the a term is just 7 cubed, or z cubed. The b term is just 125. So the sign that separates the two has no effect on the actual number that you're looking at. Other questions? So if you look at the second one, letter B, we have 81 y to the 4th plus 192 y. So what do you notice first, Ava?
You take out 3y.
Yeah, so we have to take out a y. They have a y in common. Sometimes you have to factor a couple of times to work through the problem. Ava, if you take out a y, what do you get?
You get 81 cubed
Did you take out something else too?
I took out a 3 as well.
Yep, okay, so let's go back.
I was just thinking.
Nope.
Sorry.
So you took out a 3 and a
Y.
y. So they have a 3 in common and a y. Okay, so Ava, go back. If you take out a 3, you get 27y cubed and 64. There we go. So GCF, what are they both divisible by? Well, they're divisible by 3, and they also have a y in common. So the next step, then we have to think about their perfect cubes. So we're taking the cube root of 27 and the cube root of 64. The plus sign has no bearing on the number. That plus sign helps us factor with the pattern then. So Ava, the cube root of 27 is 3. And the cube root of 64 is 4. So here's my A and B terms. So A is 3y, B is 4. So then I'm factoring it AB, A squared, AB, B squared. So AB, A squared, AB, B squared. So represents the symbols in the middle. So plus sign, same sign. Opposite sign, always ending with a plus. So Ava, that would look like
3y plus 4. 9y squared.
right? So you're squaring the 3 and the y,
Minus 12y.
and then you're multiplying those two together. So 3y times 4. And then you end with b squared, which is 16.
And would you put the 3y?
Excellent. The last thing that we need to do is make sure that that GCF goes in the front. Factoring it completely has to have all of the pieces of the problem. So the GCF and then the rest of the factor. Questions? So there are two more at the bottom of this page yet?
Yeah.
See if you can try and use the perfect squares to factor them. You might have to take a GCF out first. So first question, do they have a GCF? Like in number 2, you're probably going to pull out a negative GCF. Kind of get that problem to flip so the C term is first. First question we always ask ourselves with factoring is, what is the GCF? And that second one, pull out a negative 2. Pull out a negative 2, that makes us have a positive C cubed. It's nice to have the variable be positive when you're factoring. Don't forget that GCF in your factored form. Don't forget to ask him. Need to ask David about soap. Sadie, what's the cube root of x cubed?
I got x plus 2.
Good. So A is just x and the B is 2. And then Sadie, what does it look like in the next set of parentheses?
X squared minus 2x plus 4.
Thanks. So again, A, B, A squared, A, B, B squared. And then the SOAP represents the symbols in the middle. The last thing, we took out an 8. Don't forget the 8 in the answer. Yeah, GCF. Don't forget about the GCF. So the second one, I pulled out a negative 2. And by pulling out a negative 2, that makes that C squared positive, or C cubed positive. So we have a C cubed and 125. JT, how'd you factor that one? So my A term is just C. The B term is 5. The cube root of 125 is 5. And then again, that negative 2 was the GC. So there are a few other factoring problems. Because not only will we have factoring with these patterns, but we're also going to have other types of factoring. And the directions will say to factor the polynomial completely. So here we have x cubed. So again, looking at that larger power, no longer just x squared. We have a negative 2x, a minus 9x, and then a plus 18. And it says to factor by grouping. So we now have 4 terms to start with instead of just 3, or 2, which we usually don't have 4 terms to start with. We usually have 2 or 3. How do you think factor by grouping works? Nick?
Group the first two terms together and the second two terms together.
Yeah, so essentially, the way it's written, you're going to pair things together. That's what factor by grouping does. So kind of think, put a little line down the middle there after the second term. We're going to look at these two things and kind of see what they have in common. So Jack, what do the first pair have in common?
X squared.
X squared. And if you take out that x squared, you have
X minus 2.
x minus 2. And then the second pair, Jack, what do they have in common?
Negative 9.
A negative 9. And in parentheses,
X minus 2.
x minus 2. So factor by grouping. You're pairing terms together because they have something in common. And then, Jack, what would you do?
X squared minus 9. And then x minus 2.
Right. So factor by grouping. And generally, probably like 75% of the time, the first two pair together, the second two pair together. Sometimes you have to rewrite it. So the directions say to factor the polynomial completely. So we've done factor by grouping. You need to look at your answer and ask yourself if there's any other way to factor it using the 4 methods that we reviewed at the top of the page, the front page, or using the 4 methods that we reviewed yesterday, any of the methods that we talked about in chapter 4. So if you look at those 2 parentheses, because those are our factors, can either of those parentheses be broken down further? Here? Right, so the first one is a difference, because it's a minus sign, and these are perfect squares. So because of that, we can break it down further, and he said x plus 3 and x minus 3. So this term is still squared. It's still a perfect square. The next one is just an x minus 2, and when it's just an x by itself, it can't be broken down any further. That's prime. So if I just have an x with no power attached to it, that's as far as we can go. So that's 2 types of factoring, grouping and perfect squares. Stephen.
For the x plus 3 and x minus 3, can you just do the symbol plus minus with 3?
No, we're writing them as separate factoring. Other questions? Nina.
If there's like another number like added like multiplying x, like it's like 2x plus 2, would you like reduce that more to be like x plus like 1.5?
No, that's a good question. So if you, factors are whole numbers. So if you factor something out and make it a decimal, then you've gone too far. Really good question. So if there was a 2x plus 4, then we could pull out a 2. But if they don't have anything in common, then we can't break it down any further. So I think there are 3 more examples. I don't think we'll get to all of them. Let's do number 2. We'll do 2, and then if we have a chance, we'll go back to 1 and 3. We can skip around here. So number 2 says x to the 4th minus 14x squared plus 45. Chris, you have an idea? What do you think?
You could multiply x 4 times 4 times.
Okay, so there's really a 1 in front, so he said multiply. And that gives us 45.
And then make
-9 and
-14, that's -5.
-5. So this is still a trinomial. The trinomial is when there's 3 terms. It doesn't say x squared anymore like it did last chapter, but it still meets that same pattern. So a trinomial can still be factored. So now we have a -9 and a -5. When we factor this, we're starting with x to the 4th. So x to the 4th is my largest power, and that power stays there. And then when I write -9, that -9 has an x squared with it because that middle number is x squared. And then there's a -5 that also has an x squared. So whatever the middle number is, usually it's an x. Well, now it's an x squared. So that has to follow with our values that we're inserting. So Chris, if we now factor this with grouping, what do the first two terms have in common? And then you would have in parentheses, the second two terms have, and that would be also x squared minus 9. So the power of 4 can still be broken down. Now I have x squared minus 5, and we have x squared minus 9. So looking, these two factors are in our parentheses here with x squared, because x squared times x squared is how I get x to the 4th. So again, before you're done, look at your answer. Can it be broken down any further? Nina, can it be broken down any further?
Yeah, you can break down the last parentheses.
Yeah, because can you take the square root of 5? No. And again, no decimals. So if you can't take the square root of the number, keep it. Nina, how do you break down the x squared minus 9?
Would be x minus 9.
What's the square root of 9?
Oh,
Yeah. But I can't take the square root of 5. It's 2.24, blah, 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 blah. So if you can't break it down perfectly, then keep it as is. So your homework tonight is a bunch of factoring. We're going to do more tomorrow. This is definitely more involved. So the factoring is probably 2 parts because the power is higher. So it's on page 356 and 357, and it's 3 to 23. I will send the answers on Google Classroom to the Eden so that you have all the solutions to check. Anybody interested in doing 15 or 22? Maddie, you'll do 15? Have a fantastic day. Gavin, you want to do number 22?
Not really, but I guess.
All right, thanks. I appreciate it, Gavin.